Hi, and welcome to another Zero to ASIC interview. And today I'm very happy to be joined by Tom Spyrou, one of the OpenROAD developers. So, Tom, nice to meet you. How are you doing today?
Oh, I'm doing pretty well. Thanks for having me on your podcast. And maybe as a brief introduction, I'm the chief architect and technical project manager of OpenROAD. I joined the project back in 2019, and I've been a longtime EDA developer. In fact, I wrote my first static timing engine in 1988 at VLSI Technology, and it was actually the first STA engine to be trusted to sign off devices for fabrication without doing timing-based simulation. I worked in static timing longer. I was the original architect of the primetime STA algorithm. From there, I managed the common timing engine at Cadence and the precursor to the open access database at Cadence as well. And I've held other senior technical positions at Synopsys, Cadence, Simplex, AMD, Altera, and Intel.
Pretty impressive. So, what got you? So, and now do you do OpenROAD development full time?
Yes, I do it full time.
Yeah. And OpenROAD is all fully open source, is that right?
That's right.
Yeah.
Everything is open source. You can see all the work that we do on GitHub.
Yeah. So, what drove you to get involved with an open source? I mean, I guess I'm just assuming that a lot of those other jobs were probably you weren't allowed to do publish stuff.
Yeah, this is my first open source project ever. When I joined, I had to learn a lot: licenses, GitHub, Git in general. How do you work in a team where everything you do is visible? So it's actually been quite a challenge to come up to speed. Everything I'd done before was closed source, like you said. And I got involved with the project partly my relationship with Professor Andrew Kong. We've worked together on projects on and off for years. And the thing that was attractive to me about it was that this was a chance, number one, to really not just incrementally innovate, but try to do something big in EDA. Of course, doing something big in EDA, first we had to build the base. And that's sort of where myself and a couple of other industrial developers can come in and help make sure that there's a solid base before we go off and try to do the big innovations.
And how long has OpenROAD been going for?
It started in 2018, so it had been going for about a year when I joined.
Okay. So like 3 years of development then?
3 years so far, and one more year to go under the current funding. Of course, we're hoping to
Okay.
extend and continue the project.
Yeah. And the funding is from DARPA, is that correct?
That's correct. Mostly from DARPA. The few others have donated a little bit, but the bulk is from DARPA.
Okay. And so I first heard of OpenROAD watching, I think, Mohamed Shalan's presentation on OpenLANE as part of the eFabulous tooling. And it always struck me there was this like central block that did some really key stuff entitled OpenROAD. So can you tell us a little bit about how OpenROAD fits inside OpenLANE?
Sure. So OpenLANE is, in terms of its use of OpenROAD, has wrapper scripts that basically run OpenROAD from RTL to GDS2. And OpenLANE provides a nice, easy entry point for users into OpenROAD. If you bring up OpenROAD standalone, it will look a lot like a Tcl-based EDA application with all the commands that people are used to seeing there. And what OpenLANE does is it wraps that and provides this automatic flow, which gets you from RTL to GDS using one of the open source PDKs. I think OpenLANE also supports some closed source PDKs, but for most of the open source users that are watching this, probably everybody's using one of the Sky 130 PDKs.
Yeah. Um, and maybe I asked this question in slightly the wrong order, but what is the aim of OpenROAD?
So there are a few different aims. The first thing is to create an open source vehicle for advanced EDA research. And what I usually tell people is I worked in EDA industry for years. When we would see academic papers, most of the academic papers we would put down nearly right away because, well, I built a new placement algorithm, but it's not timing driven. or again, it doesn't. I built a new optimization algorithm, but the static timing engine inside is not incremental, so the run times are very slow, and you can't really properly evaluate how the algorithm works. And what happened was EDA industry has gotten very far ahead of EDA research in terms of the base of software on which to develop. So one of the big aims of this is an open source vehicle for advanced EDA research. It's a base EDA system, not so unlike the commercial systems that you see. And from here, we hope to do a lot of advanced research.
Okay, so one thing that you said there that I was interested in is about how the industry is ahead of the research. Could you just expand a little bit on that?
Sure. So I think if you look at the core EDA RTL to GDS algorithms, there's been all sorts of interesting research in the, let's call it the core placement, the core routing, these algorithms. But the trick to EDA is how do you put all of these together in a way where you build a tool that can converge a design from RTL to GDS. And so the tricks of going from one step to another, optimizing for area and power and routability simultaneously. There are a lot of tricks to the trade there that really are unpublished. And one of the goals of OpenROAD is to basically create a base EDA system so that people can do real work in those, let's call them more industrial practical areas to try to improve the final result of the system.
Okay, so there's a lot of research that's being done and is in the industry standard tools, but not much is being published. Is that like a...
That's right.
Okay.
Yeah, that's right.
And do you have to worry about things like patents or anything like that?
Yeah, absolutely. We have to make sure that we don't violate patents, et cetera. As part of a university research project, which is non-commercial, we don't have to worry too much about that because it's not like we're in competition with anybody. We're just trying to push the state of the art forward. But we do think about that and try real hard to follow license agreements and all sorts of other intellectual property protection.
Okay. And you were very kind enough to fill in a bunch of these questions for me, which doesn't often happen. So thanks for that.
Sure.
But it's also quite interesting for me because I can pick out one of these things. So, for example, one of your points in what's the aim of OpenROAD is train the next generation of EDA developers, and I think that's a really interesting topic. Could you expand on that a little bit, or yeah?
Sure. So I think if for all of the EDA companies and anybody who wants to hire people who know about EDA, even in a design company, it's very hard to hire trained people with the right skill set. People come out even with advanced degrees, and they may not know how the tools work inside. They've used them, they've tried a couple of the fundamental algorithms, but they don't have deep knowledge of how the tools work inside, which is essential to be an expert user and also if to be a developer. So with OpenROAD and the code being open source, we can actually train people who come out with high level of expertise in how the EDA tool itself is developed and how it works.
Okay, great. Do you think that there's a shortage of developers in the EDA industry?
There's absolutely a shortage of developers in the EDA industry. Just look on LinkedIn and look how many positions are open. Ask any hiring manager who's trying to recruit. And it needs a special blend of skills. You need to understand digital design. You need to understand physical design if you're working in that part of the EDA tools. And you also have to understand complicated software development. The EDA tools have a lot of code and they're complicated, and they have to run fast. They have to represent large designs in a low amount of memory. So it is a difficult skill set to find.
So maybe a good thing to put on your CV would be to open a few PRs, pull requests on GitHub against OpenROAD or OpenLANE.
Yeah, absolutely. Then you can show any prospective person who's thinking of hiring you for an EDA job that, look what I did.
So if you've listened to the podcast or watched the videos before, then you know that I ask my guests what their favorite terminology is from the Zero to ASIC course terminology page. So Tom, what's your favorite?
Well, for me, it's kind of an easy answer to give you. It's STA, which stands for Static Timing Analysis, and it's how I got started in EDA. Logic simulations were running longer and longer, and eventually it was becoming, the verification bottleneck actually started a long time ago. And static timing analysis was EDA's first foray into how do we reduce that verification bottleneck.
So for people that don't even know what static timing analysis is, could you break that down a little bit for us?
Sure. So normally when you want to do timing verification of a device, you would apply stimulus, make sure the timing is met, look at what happens on the output of the pins, make sure the correct data is coming out at the correct time. So static timing analysis is a way to analyze the timing of a chip without vectors. So hence the term static.
So if we make a comparison to, say, computer programming, which maybe a lot of people are familiar with, there's also static tools as well as dynamic tools in that field as well, aren't there?
Yeah, that's exactly right. A dynamic tool, you probably would have to have a unit test and you would have to actually exercise the code. A static tool would run through the code and look for bugs. Yeah, there's definitely a parallel there.
So when I look at the STA reports in OpenLANE, I'm seeing kind of the longest combinational path and then checking that the setup and hold times for the flip-flops are being met.
That's right.
Are there other things that had needed to be taken into account, or does that basically summarize it?
At the high level, that summarizes it. There are other checks that have to be done besides setup and hold. There's recovery and removal. Is my clock operating at the frequency that I determined, which is part of what a setup check is. But I would say at the end of the day, it's all about making sure that a constraint is satisfied. It may not always be a setup and hold check. Sometimes there's a skew check, for a particular bus if all signals of the bus have to be clocked together, and those constraints can also be entered in STA.
Great, thanks.
Sure.
Always like learning a little bit more deeper about these topics. I think one of the things that a lot of us, when I say us, I mean people new to this who've been brought in from the Google Skywater eFabless collaboration. And so my only experiences with these tools and with the Sky 130 PDK. And so I've kind of just assumed that that's the only PDK that we've got accessible. I know there's like the Oklahoma State open source ones, but I don't think that's fabricable. What other processes or technologies has OpenROAD been used with?
Sure. And I think you meant the Arizona State University PDK. So they have done ASAP 7 and are working on ASAP 5. And you're right, those are not manufacturable. I think definitely OpenROAD has been used to tape out designs at GF12, GF55, TSMC 65, and Intel 22.
Okay, so there's actually a lot of extra stuff going on in the background that's...
Yeah, absolutely. Now, these, of course, are private PDKs, so you won't hear about that. It's the usual thing where somebody has a direct relationship with those foundries, gains access to the proprietary data separate from us, and then they use OpenROAD to do their chip design in that technology.
Okay. And what's the take up on that? Like how many people are doing that?
I would say the take up is a lot higher on the open source PDKs for obvious reasons. So I would say in terms of private PDKs, the number of people doing it is probably still less than 10.
Okay. And we've had like over 100 applications for MPW 1 and 2 so far. So
that's right.
A lot of people using it. Okay. And yeah, go on.
Oh, I was just wanted to mention that I think it's really important for OpenROAD to support advanced nodes, because part of this open source tool suite that could be used to train the next generation of developers as a platform for research, it has to be able to handle advanced nodes. Otherwise, how important is that research?
Yeah, it needs to be relevant.
Right.
Yeah, it's quite easy to write off open source stuff sometimes as kind of experimental or just like what's the use of it. But I think, yeah, it's great to see actual chips, actual silicon coming out and people getting silicon proven designs. And that definitely the next step is going to be other nodes. I've spoken to a few people who are very keen, but they need much bigger memories on board, so they need these much smaller
Hmm.
process sizes.
Right, right. Yeah, absolutely. It makes sense. And I hope that the phenomena of open source PDKs doesn't stop here with Sky 130, that we start to see more advanced nodes come up with open source PDKs available.
Yeah. What do you think? Is it going to happen?
Yeah, I do believe it'll happen. I think that always people working on bleeding edge technology will need to keep it secret so they can recoup all of the investment they made. But for the older technologies, which are quite valuable, even if you're not on the bleeding edge, you can do a lot with something that's just a few years old. And I think there's enough interest from major companies in having open source PDKs that it will eventually happen.
Yeah. I was having a conversation with somebody the other day about how when you're on the bleeding edge and you're competing like in the CPU or GPU space, then those tiny advances in efficiency and power or area are crucial and gives you the competitive advantage. And that's why people pay
Hmm.
a lot of money for the like the big name tools. But if
That's
you
right.
have a new design or like a especially like a maybe a mixed signal design that can really make use of what we have available on an ASIC, then your design doesn't need to be using cutting edge or like getting the absolute maximum power or area efficiency because it's doing something new, and your unique thing is that you're competing in a new area.
Yeah, that's right. It's kind of like anything. Once a particular application matures, then it's going to be all about hyper optimizing that application and getting every little bit that you can out of it. But at the beginning, when an application is new, just getting something into silicon and getting it out of software is such a huge benefit. And I think a lot of OpenROAD users will be people who are innovating in that area.
Yeah, yeah. I think yeah, you can look through the applications on MPW 1 and 2 and start to see that happening. And especially, I think one of the interesting areas here is the embedded FPGA fabric that people are working on.
Hmm. Yeah, absolutely. I spent some years at Altera, and I know how hard it is to bring up an FPGA and make it work. So it's really exciting to see an open source FPGA like that available that people could embed into their devices.
Yeah, RISC-V with an embedded FPGA extension. Watch this
Right.
space. Yeah. Um, okay, so maybe you could tell us a little bit about the roadmap for OpenROAD going forwards.
Sure. We have a long roadmap and a lot of things that we want to do, like any software project. But I think, just to focus down on a few of the more important things that we're looking at. One is improving PPA, or power, performance, and area, basically the output device that comes from OpenROAD. Trying to make it smaller, faster, use less power is pretty critical. We've also, in terms of pushing the forefront on that, we've created a new machine learning metrics capability, and we plan to leverage machine learning a lot more going forward to improve PPA and also to improve the capacity of the tool. Another area of focus for us is how do we utilize cloud scale compute to both improve runtime and performance, take the problem, break it up, and then really be able to run expensive algorithms on it. Today, there's always a trade-off between PPA and runtime. Everybody wants the best chip possible, but they only want to wait so long to get it. And so I think the cloud scale compute availability has something really big to offer to EDA. And then, of course, we have a long list of requested features that, I'd call it missing functionality that we want to fill in.
Which of these, they all sounded quite interesting. Which is the kind of the one that is the most interesting to you?
For me personally, for a long time, I've had a real interest in parallel processing, cloud scale compute. If you Google my name and distributed processing, you'll see a bunch of articles and papers that I've written over time. So for me personally, that's an area that I plan to spend a lot of time on.
Great. Did you read that recent Google paper about using machine learning algorithms for floor planning?
Yeah, I did. It looks really exciting. I think using machine learning to advance the state of the art and what's possible. And, most of our EDA problems are NP hard. You can't actually prove that you have the best solution when you have a solution. And I think machine learning is a great thing to add to our bag of tricks to make things better.
Are you worried that you're going to lose your job to the machines?
No, I don't think so. Excuse me. Writing software is hard, and writing software that does machine learning is also hard. So I think I don't worry much at all about machines being able to develop themselves and their own machine learning algorithms, at least not in my lifetime.
How about chip designers, though? Should they be worried?
Well, again, I think it's like any industry. If you're doing a vanilla chip that's very simple, perhaps, increased automation will require less chip designers working on that. But if you're working on the bleeding edge, it's so hard to hyper optimize these chips and it's so competitive, and the metrics that people are trying to achieve in terms of low power, battery life, et cetera, are so difficult that I think I wouldn't be worried either.
Okay, so moving on then, what is your favorite part of being involved in OpenROAD?
Well, there's several favorite parts, but I think my most favorite part, I'll say, is working with people who really want to innovate beyond small incremental innovations. OpenROAD is really trying to build a base then for people to do big, risky innovations. And that's really my favorite part of the project. Maybe if you let me answer a second favorite part, it's been exciting for me to see how OpenROAD is greatly expanding the field of who can design a chip. I think even high school students now are able to design a chip with OpenROAD wrapped inside OpenLANE. And to me, that's just really exciting to see.
Yeah, I mean, I'm sure I owe you personally a lot for your work on this because as a complete newbie in this field, I've only just completed my second tape out ever, and it's amazing to me that's even possible. It's an amazing time to be doing this kind of stuff.
Yeah, yeah, absolutely.
It would be really interesting to hear more about the recent announcement about OpenLANE and OpenROAD.
Sure. OpenLANE team and OpenROAD teams have been working together closely for quite some time. In fact, I would claim that OpenLANE was able to wrap OpenROAD before OpenROAD was even ready and get useful devices out of it. So we've been partnered with them for quite some time. What we've decided to do now is bring OpenLANE and OpenROAD more closely together. So the main vehicle for people running their designs through the flow will move from the OpenROAD flow scripts that we had been providing from the OpenROAD project to OpenLANE. And so if you go to the OpenROAD project area now, you'll see OpenLANE there. It's been upgraded to the absolute bleeding edge of the OpenROAD application. And we're really looking forward to even working together more tightly than we have been.
And that's all now already live on GitHub, isn't it? If you go to the OpenROAD organization, you can see OpenLANE in there.
That's right. You can see it today.
And what's your hopes for the future of this collaboration?
Well, the hope is that we continue in the direction that we've been going. It's one thing to build a tool, and it's another thing to build a flow that can actually complete a chip that is working. And the OpenLANE contribution to open source EDA and using OpenROAD has really been to put that wrapper on top of it and to ensure that the technology is easily accessible by many people.
Are you excited to have so many people using the tools that you've been working on?
Yes, I'm very excited, of course, to see so many people using it. With all of that use comes lots of requests and lots of work and lots of hard priority decisions to make. But yeah, it's really gratifying to see so many people using it, and to be able to say there's been more than 100 tape outs now is great.
Yeah, that's really excellent.
Yeah,
Congratulations.
thanks. It goes to myself and the whole team. There's been a lot of people behind this and a lot of blood, sweat, and tears that have gone into this over the past couple of years.
Yeah. Okay, well, Tom, thanks so much for your time today to talk us through all of this. It's been really interesting and insightful to get your feedback on this.
Well, thanks for having me, Matt. It's been my pleasure.